interception infiltration. Okay, and the first part is an interception. The rainfall is intercepted by the vegetation and evaporate to the air, and the volume of water can be called interception. There are three possible routes for interception. The first is interception loss, and is retained in by vegetation and surface storage and evaporated. Two is mean true fall, drip of the plant leaf to the ground surface, and third one is stem fall, rainfall run through the leaf and the branch and down to the stem and ground surface. This graph shows the relationship between the plant density and the interception rate. Consider this horizontal axis is plant density and is vertical axis is interception rate. We expect that the for the first one is the dashed line is cone compared to the same density. The cone gives the more interception loss because of the big leaf of the cone. And the second is soybean, and the smallest one is oat. Okay. This figure shows the another factor that interception loss is a function of the rainfall intensity. If the rainfall increases, the interception loss is smaller. Once the rainfall arrives the surface, we store in the depression storage. Okay. And the rainfall reach the ground, and before it can flow over the surface, they have to store in the depression storage. And eventually it's lost to the infiltration or and evaporation. Infiltration. Infiltration is the process of water penetrate from the ground surface into the soil. Okay. This figure shows the distribution of the soil moisture. We can draw. This one is like that. Is soil moisture and is a depth. At the surface, the saturation zone is occur on the surface, and the bottom one we call the dry and wetting zone, and in between is transmission zone. So there are four moisture zone in the in vertical profile of the soil column. And for infiltration rate, we use small f to express in terms of the is similar to the rainfall in terms of depth per time, inch per hour, centimeter per hour. Okay, it's a rate at which the water enter the soil at the surface. If the water is poured on the surface, the infiltration occurs at the potential infiltration rate. Okay, that is another term of the infiltration. And the third term is we call the cumulative infiltration. It's the cumulative depth of the water infiltrated. So this is equation for accumulated infiltration depth is an integration of the infiltration rate is with time, and this is equation for infiltration rate. It differentiate of the cumulative infiltration with time. So we can draw the picture that's like this. Infiltration is it decreases with time, but for the accumulated infiltration is increased with time. The maximum rate at which the ground can absorb water we call infiltration capacity, and we use F star to represent the infiltration capacity. And the volume of soil or water that ground can be hold we call the fill capacity. Okay, the other many factors affect the infiltration. For example, this one is this graph to show the infiltration rate with time. So the difference. The bottom one is the bare soil. It means no vegetation. The second is 80% vegetation cover. And the 30% vegetation cover. So it's high high vegetation cover. The high give the high filtration. And this figure shows the difference of the soil texture. The bottom one is clay soil compared to the gravel and sandy loam. Okay. This one shows the relationship between the rainfall intensity. This one rainfall intensity with the infiltration rate. Okay, that is infiltration rate. And the runoff generation. This runoff generation rate. So it's water balance of the water. This figure shows the relationship between the rainfall. The top one is rainfall with time. It's the rainfall intensity. And the second figure shows the runoff rate. The same unit, and the bottom one is the infiltration rate. So we can write equation for this. We can write equation like this. Here is the ground surface. The rainfall coming. And the infiltration through the ground. And this is F star is maximum infiltration, and some part of the water is flow out on the surface. If it cannot infiltrate it, we call it QS. So this is a QS. So that is the relationship between. You can write equation for infiltration. Sorry, this is an infiltration equal to the rainfall if the rainfall is less than infiltration capacity, or the rainfall infiltrated. Okay, but if rainfall is greater than infiltration capacity, the infiltration is about equal to infiltration capacity. And for QS is 0 because of our rainfall infiltrated. The same condition, P less than V star, and the rainfall QS is equal to subtract between P and if F star if rainfall is greater than F star. So that is a basic water balance equation to explain the happens on the surface of the soil. And the next topic is about the measurement of the infiltration. So we use one we call a simple tube-type infiltrometer. Okay, there is two single ring or double ring to measure the direct measurement from the soil. And also another method using rainfall simulator or hydrograph analysis to estimate the infiltration.